Hello guys, and welcome to our next tutorial about concurrent programming. Today's topic is creating sequential download manager using Python, and as a code base we get the Golang code. I've been searching for a great tutorial about using concurrency in real world example, and I found one. This tutorial is from Muhammad Usman, so kudos to him, and he did a great job on explaining how to build a concurrent download manager with pure Golang. And I instead just divided his tutorial in two parts. The first part is building sequential downloader, and the second part is building the concurrent downloader. And instead of explaining the Golang code, I'm going straightforward directly to translate this Golang code to the Python. I'm going to put Muhammad's explanation video in the video description, in our video description. So you need to first to look at his explanation, and then just come back to this video to see how we can actually translate the Golang code to the Python code. If you do not want to watch the Golang video, then just go ahead with our. Let's just start and translate the sequential downloader Golang code to the Python. So what we have here, we have a type download struct. We are not going to do this thing with the Python. We are going to replace this with a dictionary in Python, and basically we have a main function. So let's just start by implementing this main function. It has no arguments. It has a start time. So for start time I'm going to use the date time now. Then replace the microsecond with 0, and of course from date time import date time. What happened here? Oops. Time. Nice. Then we need to create this dictionary. So d equal to, and let's just paste it here. Nice. So what we have is that URL of the file which we are going to download, the target path where it should be stored, and the total sections. So the base idea is just we need to divide this downloadable file in chunks. At this time we are going to divide this file in 10 chunks of bytes, and we need to download this bytes, so chunks, concurrently. But instead we are going to download for now as a sequential order. Then we have this do function. So I'm going to call this do here with past dictionary. Then there is a totals seconds, and again date time now, replacing this microsecond part, then just subtracting the start time, and there is a print statement which indicates a download completed. So we're going to use f-string download completed in there's total seconds and seconds. That's it. So this is the main function. Basically, then we need to implement, let's just grab it here, this do function. So def do, So first of all, the printing the making connection. So print making connection. And again, too many typos here. And there should be the get new request function. This just instead run it as a placeholder, but we will implement this get new request further, and it should accept actually this data, and it is a dictionary. So what we have next, we have this got section. I'm going just to post it here. So we are just printing this got the response status code, and this status code is must be actually 200 in order to understand that it's exactly the success. Then we need to implement the same thing here, so return errors. So if the status code is greater than 299, we need to raise as an exception as we did with Golang section. Then we need to get this content length header from the response object. Let's just implement this. So we got the response headers as a dictionary, and we get this content length key value size. Then we print it as we did here with Golang. Nice. Then we need to initialize the sections, the chunks or the portions of the downloadable file. And what we have here, so we need to implement a list of lists in Python to make available as a placeholder. So first, let's just example, if file size is 100 bytes, our section should be like, so 0 to 10, 11 to 21, 22 to 32, and so on, so forth until this 99 section. And so we need the list comprehension ranging through the data total sections, and as we remember the total sections in 10, it should be should give a result as this one. So if we run the sequential downloader .go, so making connection as we want, the printing the thing. So the got response 200 is the response status code. Then each size is the total file size is this bytes. Then we have so we didn't divide yet, so we divided by 10. Each size is here, and this is the thing we want. So in Golang, we need to make a slice of integers and give a length. But with Python, we have such the function call. Instead, we are going to use this list comprehension. And again, we need to calculate the each size. So each size for Python is, so we get the size, converted to int, and divided by 10, because the data total sections is 10 for now, for us. And then we are printing this. So the each size is this bytes, and the sections is this one. What else we need to do? Let's just scroll down. Yeah, we have this range for loop for updating our list of lists. And this is quite straightforward. I'm just going to copy this. We have translated this Golang to the Python as it is. And then again, we need to print these sections. So what we have here, So we have updated these sections by going through each section, and we again need to update these sections with the chunks. So this print sections is this one. Nice. What we have and here with Golang, the last thing is that calling this the actual download sections where the download processes happen, and we just call it. So for index a section enumerate the sections again, and we are going to call this download section function, pressing their index section and the actual data. Nice. So we didn't implement yet this get new request and the download section. We are going to do is next. So after the do function, we have this get new request. So with Python, we are going to use request package. So you need to install it. Just pip install requests. It is a de facto and the default the package that many people like using here. For get new request, so let's just implement it. So def get new request, and it needs the method, the HTTP method. It's a type string. The URL is a type string again, and the headers. The type is dict, and by default it's not. We are not passing any headers to the get new request the function, and the return type is requests response. So we are going to return the response from the request package, but first of all we need to just import. So import requests. Nice. So what we have here, I'm just going to copy my notes from my notes. So what we have, we are doing calling the request method, passing the method of the request, so post, get, head, any type. So here we are doing like get. This is a HTTP verb, and we are passing the URL which we need to get or post, and the headers, the updated headers, or you can get the response and set the header and return from this get new request. Great, and we have here this download section function where we are doing the actual download. Let's just implement it. Oops. So what we have, so the download section should accept the index section and the data. So def download section, and it has so index should be integer, and the section is list of lists, and it's a list type, and the data is a dictionary type. And but here we need to set the headers with that range. So we need to give the chunk range, the byte range, where we are passing to the get request, and it will get this amount of bytes. Let's just translate this code. So this code is basically this thing. So bytes, the first index, first value, and the second value. So we are passing with this one, and this is a chunk boundary. So first chunk and first bytes and the end bytes, the start bytes and the end bytes. Nice. Then what we have, headers. and we are passing this to the get new request with get method. So as we describe here, we are passing the URL, the method, and the updated headers to the get new request method. And we need to print this downloaded bytes for section. This is here. It's the equivalent here. And what we have is just print this. Oops. Just here. So the print statement is so downloaded the response headers getting this content length as here. So gets the content length bytes and pass the section index and the section itself. So the section index and section itself. Nice. Then what we have, we need to create this file. So we need to create this temporary file as the section TMP indicates. So I'm going to just create a file name, and give it the name. So section index, the past index, and TMP. Then we need to call with open this file name, and we need to write the bytes here as local file. Yes, and write the local file, right into the local file, this response content. Nice, very nice. The same thing we did with the Golang. So we are reading as the response body, then we are writing to this file these bytes, and if there is no error, we are just returning the nil, so that indicating the success of the file download. And let's just test our Python, sequential Python downloader, and I think there is nothing left here, so we have totally translated all of the code, and just this removing this section files, and yes, there is no, and it's just the remaining thing is just adding this code as I want to directly call it from the IDE, so calling this the main function. Right, let's do the sequential. So making connection, got 200 the bytes, the output is exactly the same. Just download completed in 8 seconds, and let's just compare. Oops, I removed this screen. This is exactly the same result with the Golang code. We send a GET request, we are making connections, there's a success code, we calculated the total byte, divided it by total sections, initialize the list of lists with the chunks boundaries, gave the bytes here, and started to download each section to the different, the appropriate file. So section 0, section TMP, let's just show the, oops. Yes, each section is given byte length. We just remove this age. Yeah. So we have translated the sequential Golang downloader code to the Python using this using the request package. So the next thing is to add the concurrency to this Golang code and to do the same thing to the Python code. See you in the next video where we are going to do the actual concurrent run. Okay, bye.